Hi guys. So today we're going to talk about solving trig equations. So first I wanted you to remember what it means to solve something, right? It means to figure out what the value of the unknown variable is. Okay? So it's the same idea as remember at the very beginning of grade 9 you guys had to do for example, solve that, and then you guys would subtract 1 from each side and you guys would get 2x is -1, and then divide by 2 on both sides, so you get x is -1/2, right? So that's what solving an equation is, and now we got to solve a trig equation. Okay, so we're always going to be between 0 and 2 pi unless it says something else. Okay, so this time it says between 0 and 2 pi. If it doesn't say anything, then you assume it's between 0 and 2 pi. Okay, so let's start solving, right? So you can see what you need to do is we need to isolate x. Okay, so even before that, what we're going to need to do is we're going to need to isolate sine x. Okay, so what we do is we need to first get rid of that 1. So that means we're going to add 1 to both sides, right? So I add 1 to both sides, makes this one go away and gives me 1 here, and then I divide by 2. So I get sine x is equal to 1/2. And now between 0 and 2 pi, when is sine x equal to 1/2? Do you guys remember? So remember, x has to be pi by 6, right? And now remember, if x is pi by 6, remember sine x is positive. That means, C A S T, so sine is positive, means I should get an answer here and here. So there's pi by 6, and my other answer should be there with pi by 6, which means that that answer there is 5 pi by 6. Okay? Alright, so that's the first one. Okay, here's the second one. A little bit more challenging. There's going to be more steps involved. So remember, the first thing is let's isolate this cos 2x. Okay, so I got to get rid of that 2. So cos 2x is -√3 over 2. Okay, simple enough. Now, the problem here is that we've got 2x in there. Okay, so for now, let's just call that guy theta. Okay, so let's solve the equation cos theta is -√3 over 2. Okay, so we know from our special values, right? So there's C, A, S, T. Cos is negative here and here. Cos is positive there and there. So we know that for pi √3 over 2, the reference angle is pi by 6. All right? So that means that to get answers in these quadrants, that's got to be pi by 6, and that's got to be pi by 6. Right? So that means that our solutions for theta are, that's 5 pi by 6, and this here is, so that's a full pi, and then another sixth is 7/6 of pi, so 7 pi by 6. Okay, now remember, that's theta. Theta is 2x. Okay, so let's go back to red now, and so we've said that 2x has to be 5 pi by 6 and 7 pi by 6. Okay, so that means that x could be 5 pi by 12 if I divide both sides by 2, and 7 pi by 12. Okay? Now, the question is there any other solutions? Okay? Well, we're going from 0 to 2 pi. Right? Both of these solutions are pretty small. Okay? I'm going to show you what I mean. So remember, cos x looks like that, and what we found is when cos theta is -√3 over 2, was 5 pi by 6 and 7 pi by over 6, right? So that's about here and here. Okay? Now the problem is that we're working with cos 2x. Okay? You remember what that does to a trig graph, right? It makes it go twice as fast. So we're gonna, so there's pi, and then there's another pi, right? So you see this 5 pi by 12 and 7 pi by 12? Well, where are those solutions with reference to this? Well, they're here and here, okay? Because negative root 3 over 2 is somewhere down there, okay? So there's a solution, and you'll notice that there's two other solutions, okay? So because this period is compressed, we're actually going through the period twice, right? So remember, it's like going around the Ferris wheel 2 times, right? We're going to hit that height once, twice in one cycle, and then again once, twice in the next cycle. Okay, so we are actually going to have 2 more answers, and our 2 answers are going to come from the fact that we are going to add pi onto both of these because it's going to be one cycle later. Okay, so that means that this is going to be 5 pi plus pi, which is going to be 17 pi over 12, and this is 7 pi plus pi, which is going to be 19 pi over 12. Okay, so this is a much more complicated situation, which you're not going to come across that often, but you need to understand that your period definitely affects the number of solutions that you have. Okay, so here our period was twice as small, which means that in this time we're going to go through the period twice. So we should have twice as many solutions. Okay? Alright, so here's a couple of more complicated situations, but simpler in some cases, because notice that our period is just 2 pi, right? And we're just looking for the solution between 0 and 2 pi, right? So a little bit easier. But more complicated because we have sine and cos all at once. Okay, but what do you notice that you should have seen at the beginning of grade 10, so at the beginning of first semester, right? If you see a sine and a sine, right, what can we do with this expression to make it a little bit better? Well, we can common factor. So sine x, and then I have cos x minus 1 is equal to 0. And now you should remember that if two things multiply to give you 0, then either sine x is 0 or cos x minus 1 is 0, which means cos x is 1. Okay? So now all we have to do is solve these two simple equations, right? And the way that I'd like you guys to do this is either you remember what the answers are right away, or you remember the graphs. So the graph of sine x looks like that. And when is it 0? Well, 0. That's pi. And that's 2 pi. Okay? And what about cos x? Well, cos x looks like that, right? So when is cos x equal to 1? Well, it's equal to 1 there, and it's equal to 1 there. Okay? So that means that x is 1 at 0 and at 2 pi. So that means that in total, our solutions are x is 0, pi, and 2 pi. Okay? All right. So remember, we factored first, and then we solved. So what about this one? Okay, so again, you can see that we're going to have to try to factor. Again, the period is just 2 pi, and we're only going to solve on that one period. Right? And do you remember disguised quadratics? Okay, so see how here we've got a squared, here we don't have a squared. So what I'm going to say is I'm going to say something like let y represent sine x. And then I have y squared minus 2y plus 1. Okay, and now when I factor this, I need two things that multiply to 1 add to negative 1. So that's -1 and -1. So that tells me that y is equal to -1, which means that sine x is equal to -1. Okay, so again, let's look at our graph. So there's sine x. When is sine x equal to -1? Well, right there. And that value, remember, that's 0, pi, 2 pi, and that's right in the middle. So 3/2 of pi. Right, so there's a half pi, pi, 3/2 of pi, 2 pi. So x is equal to 3 pi over 2. Alright, so that's it. Please try your assigned homework, and I'll see you guys ready to go tomorrow. Enjoy the rest of your day.